The ocean plays a fundamental role in regulating the Earth's climate, acting as both a heat reservoir and a dynamic participant in the global climate system. This regulation occurs through a combination of physical, chemical, and biological processes. Heat absorption and distribution. The ocean absorbs a significant amount of the solar radiation that reaches the Earth's surface, particularly in tropical and equatorial regions. Water has a high heat capacity, meaning it can absorb large amounts of heat with only a modest increase in temperature. This allows the ocean to store vast amounts of heat energy, which is then redistributed around the globe via ocean currents. Ocean currents. Ocean currents are a major mechanism through which heat is distributed across the planet. These currents, driven by wind, the Earth's rotation, and differences in water density, transport warm water from the equator toward the poles and cold water from the poles back toward the equator. This process helps to moderate global temperatures, making climates more temperate. For example, the Gulf Stream carries warm water from the Gulf of Mexico across the Atlantic Ocean, warming the climate of Western Europe. The ocean acts as a carbon sink, absorbing about 25 to 30% of the carbon dioxide emitted by human activities each year. CO2 is dissolved in seawater, where it undergoes a series of chemical reactions, including the formation of carbonic acid, bicarbonate, and carbonate ions. Some of this carbon is eventually sequestered in deep ocean waters and sediments, effectively removing it from the atmosphere for centuries to millennia. This process helps mitigate the greenhouse effect and slows the rate of global warming. The thermohaline circulation, often referred to as the global conveyor belt, is a deep ocean process driven by differences in water temperature and salinity. Cold, salty water is denser and sinks, while warmer, less salty water rises. This circulation plays a critical role in distributing heat and nutrients around the world and influencing long-term climate patterns. Disruptions to this circulation due to climate change could have profound impacts on global climate, potentially leading to extreme weather events and shifts in climate zones. Marine organisms, particularly phytoplankton, also contribute to climate regulation. Phytoplankton perform photosynthesis, absorbing CO2 and releasing oxygen. They form the base of the marine food web and play a critical role in the ocean's carbon cycle. When phytoplankton die, some of the carbon they contain sinks to the deep ocean, contributing to long-term carbon sequestration. This biological pump is a key component of the Earth's carbon balance. In summary, the ocean is a crucial component of the Earth's climate system, helping to stabilize temperatures, absorb greenhouse gases, and distribute heat and nutrients globally. Understanding and preserving these oceanic processes are essential for mitigating the impacts of climate change.